Now, if all dividends are growing at a constant rate, say g, then we can actually figure out what the future dividends look like. Going back to our original infinite sum formula, we can substitute in, because we know that the dividend at time 1, the dividend to be received a year from today, will just be today's dividend times 1 plus g. Likewise, the dividend to be received at the end of year 2 will be year 1's dividend times 1 plus g. But of course, year 1's dividend was today's dividend times 1 plus g. So if we put that in, we see that the dividend at time 2 is today's dividend times 1 plus the growth rate compounded for 2 years. In the same way, the dividend at time 3 is today's dividend with the growth rate compounded for 3 years. So again, we put this into the infinite sum formula, and we see that this is a perpetuity with a constant growth rate. And a constantly growing perpetuity also has a simple valuation formula. It's just next period's dividend, or cash flow, divided by k minus g. So let's do an example of this. Let's take the same example as we had before, where our stock pays $2 per share dividend, but assume now that the growth rate is 3% per year. So in 1 year, we'll receive $2. The following year, $2.06, a 3% growth of that dividend. The next year, $2.12, where I've rounded here, that's another 3% growth over year 2's dividend. And in year 4, again, we've rounded, but you see that it's compound growth. We're not just adding 3 cents per year. The value of the stock then is just the $2 dividend that is received in 1 year, divided by 11% minus 3%, k minus g. This turns out to be $25 per share. Let's recap. The fair price of a stock is the present value of all future dividends. Noting this, then, the unknown future stock price never enters into the formula for the current stock price. The constant growth dividend discount model allows for a simple perpetuity formula accounting for those constantly growing dividends. Now, this framework is actually quite flexible, even though so far it seems fairly restrictive in either using a constant dividend or constantly growing dividend. But if we think about this first line here, that the fair price of a stock is simply the present value of all future dividends, then we can make those dividends whatever we want. We can also use the constant growth model to simplify the calculation of dividends that might be received years and years from now. Let's see how. Let's extend the dividend discount model so that we don't have to think too narrowly in terms of constant dividends or constantly growing dividends. We can apply the same conceptual framework to any pattern of dividend payments or non-payments even. This is what we call the multistage growth model. In this model, we would make a forecast of each year's dividend in the short term, say for the next several years, and then we would forecast the timing where that long-term constant growth rate would kick in. This will allow us to summarize the constantly growing dividends in what we call the terminal value of the stock. And we can use this then to calculate the present value of both those short-term dividends and that terminal value. Let's see how this works. So here you see a timeline where I've put 6 years on the timeline, but it really represents all years beyond 6 years too. Let's see how. What if the short-term and the long-term growth rates are expected to be different? In other words, over the short term, the first, say, 3 or 4 years, the stock's dividends will grow in a lumpy manner. Well, then we can model those dividends individually, as you see on the timeline here. D1, D2, D3, D4, and D5 all represent values that we've made a specific forecast of. But we've also forecast that after year 5, stocks will grow at some constant growth rate. Or I say we forecast that, we might just assume that. We might also say that dividends just might as well be summarized by some constant growth rate beyond year 5. So we'll use the dividend discount model's constant growth formula to calculate the value of the stock at year 5. That's what you see there is V5, and we'll call this the terminal value of the stock. So in that way, V5 represents all dividends to be received after year 5. So now to calculate the value at time 0, it's a simple matter of taking the present value of D1, D2, D3, D4, and D5, and the present value of V5. So the calculation works like this. If we know D1 through D5, we can calculate V5 from the constant growth formula, and the value at time 0 is just the present value of all of those. Okay, so we'll take a specific numerical example here. Let's start with that $2 dividend to be received a year from now. Now we'll assume that we forecast that this stock will pay a $3 dividend in year 2, a $4 dividend in year 3, a $5 dividend in year 4, and a $5.50 dividend in year 5. Beyond year 5, we'll assume that dividends will grow at a 3% rate per year. So let's start and work our way backwards. So starting with the dividend at year 5, and we know after that dividends will grow at 3% per year, then the dividend in year 6 will be $5.50 times 1.03, where 3% is the growth rate. So if we bought the stock at time 5, we should be willing to pay 5.5 times 1.03 divided by 0.11 minus 0.03, or K minus G. You see that value up there as $70.81 roughly. So what we know here is that if we make it to time 5, that will be the value or the intrinsic value of the stock at that time. That's our forecast. Between now and year 5, we'll receive all of the dividends as we hold the stock. So to get today's value, we just take the present value of all of those cash flows, the dividends, and that terminal value. As you see here, that adds up to $55.74 as we discount all of those cash flows at an 11% required rate of return. Let's summarize. The dividend discount model gives us a theoretical framework for calculating the intrinsic value of a stock. Here, the intrinsic value is simply the present value of all future dividends. The calculation of this intrinsic value depends on the current or forecasted value of the stock's dividend, the discount rate used to calculate the present value, and then a long-term growth rate of dividends. I hope you found this helpful. Please see the future videos that show how to apply this model using a spreadsheet.